Assalamu alaikum, this is MD Maidul Islam Medul ID 20329 24th batch, Department of Pharmacy. Welcome to my presentation. My presentation topic is fractional distillation. In this presentation, we will learn how fractional distillation separates crude oil into useful fractions. Crude oil is the term used to describe unprocessed oil. That is oil that has been taken directly out of the group either on land or under the sea. It is an exceptionally valuable resource. It provides us with a great number of hydrocarbons, some of which are used as fuels and others are used in the manufacture of many different chemicals and even plastics. However, in the raw form as crude oil, it can be of viscous dark color, tar-like consistency, and different fractions hydrocarbons must be separated by fractional distillation for them to be useful. Before we understand how fractional distillation works, we should be clear that crude oil is a mixture of hydrocarbons with different chain lengths, some being short molecules and some being very long. Intermolecular forces act between molecules, and the longer the molecule, the greater the intermolecular force. As we can see here, the small molecules have weaker intermolecular forces and so will require less energy to break them into a gas. They have a low boiling point. The longer molecules have greater intermolecular forces and more energy. Therefore, high temperature will be needed to evaporate these molecules. They have a higher boiling point. Now we understand how chain length is related to the boiling points of a molecule. Let us look at how this method works. As we can see, crude oil is heated up to a high temperature outside of fractioning column. The hot crude oil, now mostly in vapor form, is pumped into the column, has a heat gradient and very hot at the bottom, going cooler as we moved up the top, ever at the very bottom of the column where the temperature is still high. Some long chain molecules with high boiling points begin to condense back into a liquid and are collected at the bottom of the column. The rest of the molecules start to rise up the column, making their way through bubble caps in each tray. The bubble caps slow down the rate of the rising vapors, and eventually the vapors get too cold, condense, and are collected trays. All molecules have low boiling points and so condense much higher in the column where the temperature is cooler still. As we can see, hydrocarbons with similar boiling points are collected in the same tray, and this is why they are known as fractions. They are mixtures of hydrocarbons with similar boiling points. Some examples of fractions are petrol used as fuels for cars, naphtha used in manufacture of chemical and as a fuels, kerosene as aircraft fuel, diesel oil used as a fuel for cars, vans, lorry, etc. A mixture of large chain hydrocarbons used to lay roads and on roofs. Crude oil is a mixture of important hydrocarbons, and that fractional distillation is the method used to separate crude oil into useful fractions with similar boiling points. We should understand that small chain molecules are collected at the top of the column since they have lower boiling point, and large chain molecules further down the column these have higher boiling points. This is all about my presentation. Thank you, sir. Assalamu alaikum.